Hello class, we're finally on a face fillet. So, face fillet, we're right here, the fillet type. This one we have a lot less options. So basically what a face fillet is, you're going to take, it could be two surfaces and you can create a fillet in between it. This is great for filling voids, or if you had, let's say like two edges actually that were adjacent to each other, but there were, some sort of cutouts or errors in between the edges, you can do a face fillet to get rid of it. So if you need to fill a large gap or just connect two faces together, face fillet is what you want to use. So what you do is you select your face A, face B. Right now I'm using symmetric 10. Now notice how full preview, tangent propagation, I don't see anything. Why is the preview not working? Well, if your fillet parameters are set either too small or too large, you won't see anything. So 5, too small, about 20. There we go. I'm sure if I actually sat here and measured this, wherever I would know that the 10, they couldn't touch. So you gotta pick a value that will actually span at least the gap that you're going between. Now, let's say I were to do like 30. All this does is every time you do it, it's doing, and I'm doing a symmetric circular. It's just going to take a circular, and then wherever I have a 30 millimeter radius, it's going to take the tangent to both those edges. So I think right around 20 was lowered near the edge. You can always play with the numbers just to fill that gap depending on what you want to do. So that is your face fillet. Now let's work on the face fillet with a hold line. Now I'm using these are the actual figures from our textbook. Like I say, for the following exercise, I've pretty much downloaded all these figures and removed the fillets for you and renamed them so you can work with them also and go through the motions. So now this is once again items to be filleted. I can select two faces. Select this face, and I'm going to select this. Oops. You want two different faces. I'll explain what we're doing in a second. Just get this going. Notice how I selected those two faces, and it lit up the entire edge all the way around. Once again, because tangent propagation's on. These are all tangent lines. So now, what does these are the symmetric profiles. You've got the same old profiles. But like I say, you can use any of the profiles. But here, when we have our fillet parameters, and now you have not only symmetric and asymptometric, you have what we call a hold line. What hold line does is, let's say I want to do a fillet from like this bottom edge. This would be my hold line. So I'm going to hold the line down here, but I'm not going to press it yet because I don't want to give away the fun. So when I do a hold line, I press this line, and what that's going to do is create a fillet that's originates from the line I held, which is the bottom face, all the way around. Since we have the tangent propagation, it's going to hold that line and then do a fillet up to the top surface. But the fillet, I don't have any radial value I can input. It's all going to be based on the thickness of where where the radius is. So up here it's thicker. I'm going to have a larger radius, and it gets smaller and smaller until you get to this front edge where it's going to be the smallest. So if I pick my hold line down here, notice how it's got thicker here. It held the bottom line, so that's where the fillet starts. And then it adds the radius in for you based on how thick the part is. So you get a radius and then to the tangent edge on top. So that is the face fillet with the hold line. They call it it looks more like a paddle. So that's how you can make little paddle features. Have it automatically fillet based on the thickness. Now using the face fillet again and the hold line, let's work on some other features. So face fillet times a fillet. I'm going to pick the inside here as 1 and 2. Tangent propagation, symmetric, but I want the hold line. And I'm going to work with something different. Let's do a continuous curve profile. A continuous curve, I can select for my hold line, I want to select 2 edges. So let's say the top edge here and bottom edge here. It's going to automatically do a continuous curve between these 2 surfaces, and these are my hold lines. Now, hold line, the same thing with a circular. I'm just going to select the circular here. Notice how I have still the same hold line here, but a circular, there's only one way. A circular can find from tangent to tangent. It can't make it all the way here. So this is what the circular basically profile looks like with the hold line parameter, with these 2 faces and these 2 edge lines. Basically, you have one radius, and it can't. It adds in these features when you're doing the hold line. It calculates for you. You don't have an option to pick what the actual radius is, and this is the radius. The largest radius it can do between this hold line, and still be a circular, versus the curvature. Continuous curvature can go continuously curvature to the other line. So that's the difference in the face fillet with the hold line continuous curvature. Now we get the last one, another one of the figures. I think it's one of the figure 7-73 and 7-4 from the book. This little feature here, these 2 draft edges are they come together down the center, and you can see how the I guess the angle that the intersection line is it's a low angle of coming together down here, but as you go higher on this part, the angle gets steeper. Well, if we're going to do a fillet and we're doing a face fillet, we picked this side and this side. Oops, I always keep my finger. Make sure delete. Always gotta go in that box. This is what a symmetric, let's say 10mm continuous curvature. Let's do circular. You could do, like I said, you could do actually all of the different various ones, but let's do the circular just so we can make it clear. 10mm, but because of the the angle that the 2 faces come together, it's kind of shallow here, not that steep, but the steeper it goes, this is how basically SolidWorks combines this. So what can we do? Let's do chord width. When you select chord width, it's going to go along the chord, the intersection, and make it uniformly the same. I think it's kind of hard to see when my this is more like the book. More uniformly makes a nice fillet along. It's pretty much uniform along that chord width. Versus when you do like symmetric circular, it's trying to, depending on the angle, it's trying to create that fillet symmetric, asymmetric. Oh, 20. It's actually too large. Let's see. 5. You could do, oops. Doesn't seem like that. You get the idea. So, using the chord width makes it nice and uniform all the way along the actual chord.